Welcome to the video of address resolution. At the other video before, we mentioned that hosts and routers both create routing tables to ensure that they can send and receive data across the network. But the question is, how does this information get created in a routing table? You may know that as a network administrator, you could enter this MAC and IP address manually, but the probability for making a few mistakes is great. And now it goes to the other question that is very important. Is there a way that it could be done automatically by host and router themselves? Yes, of course. It is a way, but even it is automatically, you have to understand how this works because you may have to troubleshoot a problem, or even worse, your network could be attacked by a threat actor. And at this video about the address resolution, we will explain how address resolution protocol and network discovery neighbor enable communication on a network. So we will compare the roles of the MAC address and the IP address. We will describe the purpose of the address resolution protocol, and we even describe the operation of IPv6 neighbor discovery. So let's go on and see each topic. Sometimes the host must send a message, but it only knows the IP address of the destination device. The host needs to know the MAC address of that device, but how it can be discovered, and this is when the address resolution becomes critical. There are two primary addresses that we know that are assigned to a device on an Ethernet line. There is the physical address, the MAC addresses, that used for the network interface card to network interface card communication on the same Ethernet network. Remember that. And the logical address, the IP address, that used to send the packet from the source device to the destination device, where the destination IP address may be on the same IP network as the source, or it may be even in a remote network. The layer 2 physical addresses are used to deliver the data link frame with the encapsulated IP packet from one network interface card to another network interface card that is on the same network. If the destination IP address is on the same network, then even the destination MAC address will be at the destination device. Let's consider the example that is shown here. As you can see, we have the PC1 that wants to send a packet to the PC2. And there it is displayed even the layer 2 destination and source MAC address and the layer 3 IPv4 addressing that would be included in the packet sent from the PC1. Okay, and as you can see, the layer 2 Ethernet frame contains the following: the destination MAC address, that is the destination MAC address of the PC2, the source MAC address, that is the source MAC address of the PC1, the network interface for the PC1, and we have even the layer 3 packet that contains the IP of the source for the PC1 and the IP of the destination for the PC2. So what happens when the destination IP address for IPv4 or IPv6 is on a remote network? Then the destination MAC address will be the address of the host default gateway or the router interface. Let's consider the example using a simplified MAC address representation. And in the example, it is shown that the PC1 wants to send a packet to the PC2, but now the PC2 is located on a remote network. Because the destination IPv4 address is not on the same local network as the PC1, the destination MAC address is that of the local default gateway of the router. And if you examine the router, the destination IPv4 address, you have to determine the best path to forward the packet for IPv4. So for the moment, you have to know that PC1 will encapsulate the frame, and we'll have the destination MAC address of the interface of the router, default router connecting with this LAN, and the source MAC address will be the MAC address of the source, and the IPv4 for the source and the destination will be the IP for PC1 and the IP for the PC2 as a destination. And after this, the router examines the destination IPv4 address to determine the best path to forward the IPv4 packet. And when the router receives the Ethernet frame, it decapsulates the layer 2 information. Using the destination IPv4 address, it determines the next hop device and then encapsulates the IPv4 packet in a new data link frame or for the outgoing interface. And in the example that we have, the router 1 will de-encapsulate the packet and will check the IP address of the packet, and we'll see for the next hop and see that the next hop is the router 2. So he will encapsulate the frame now, and we will have the destination MAC address will be the destination MAC address of the default gateway of the router 2 for this network, and the source MAC address will be the interface of router 2 that is connected with this network. And as you can see, the destination and the source of the IP for source and destination are the same. Along each link in a path, an IP packet is encapsulated in a frame. The frame is specific to the data link technology that is associated with that link, such as Ethernet. If the next hop device is the final destination, the destination MAC address will be that of the device Ethernet network interface card, as it is shown in the figure. So the router 2 will get the frame, and after de-encapsulating, we'll see that the IP address of the destination is at the network that is connected with his default gateway. So he will encapsulate the IP packet into a new frame, and the encapsulated frame will have the destination MAC address of the PC2, and the source MAC address will be the MAC address of the interface of the router 2 connected with the network of the PC2. And as you can see, the IP address is the same. However, we see that IP address of the IP packet in a data flow associated with the MAC address on each link along the path to the destination, it is not changed. And this process is done by the address resolution protocol, and for the IPv6 packet, the process that do that is the Internet Control Message Protocol version 6 for the neighbor discovery. And if we see the network for the IPv4 communication protocol, the address resolution, or as it's called shortly ARP, is what we need to map the IPv4 addresses to the MAC addresses. And every IP device on Ethernet network has a unique Ethernet MAC address. And when a device sends an Ethernet layer 2 frame, it contains two addresses as we discussed before. The destination MAC address, where it will be the Ethernet MAC address of the destination device on the same local network segment. If the destination host is on another network, then the destination address in the frame would be that of the default gateway. So we are mentioning that again. And the source MAC address will be the MAC address of the Internet Network Interface card on the source host. And this is a figure that illustrates the problem when sending a frame to another host on the same segment on the IPv4 network. And as you can see, to send a packet to another host on the same local IPv4 network, a host must know the IPv4 address and the MAC address of the destination device. Device destination IPv4 address are either known or resolved by device name. However, MAC address must be discovered. A device uses the address resolution protocol to determine the destination MAC address of a local device when it knows its IPv4 addresses, where the address resolution protocol provides two basic functions. It resolves the IPv4 address to the MAC address and maintain a table for IPv4 to MAC address mapping. When a packet is sent to the data link layer to be encapsulated into a new Ethernet frame, the device refers to a table in its memory to find the MAC address that is mapped to the IPv4 addresses. This table is stored temporarily in RAM memory and called the Address Resolution Protocol Table, or ARP cache. The sending device will search in its ARP table for a destination IPv4 address and corresponding MAC addresses. If the packet destination IPv4 address is on the same network as the source IPv4 address, the device will search the Address Resolution Protocol table for the destination IPv4 address. And if the destination IPv4 address is on a different network than the source IPv4 address, the device will search the Address Resolution Protocol table for the IPv4 address of the default gateway. In both cases, the search is for an IPv4 address and a corresponding MAC address to that device. Each entry or row of the ARP table binds an IPv4 address with a MAC address. We call the relationship between the two values a map. This simply means that you can locate an IPv4 address in a table and discover the corresponding MAC address. The ARP table temporarily saves the mapping for the device on the line. If the device located the IPv4 address, its corresponding MAC address is used as the destination MAC address in the frame. If there is no entry that is found, then the device will send an address resolution protocol request, and this can be shown even in the animation, where the source sent an ARP request to find the destination, the MAC address of the destination. See? For each device, an ARP cache timer removes ARP entries that have not been used for a specific period of time. The times differ depending on the operating system of the device. For example, the newer Windows operating system stores the ARP table entries between 15 and 45 seconds, as it is illustrated in this figure. Commands may also be used to manually remove some of the entries in the ARP table. After an entry has been removed, the process of sending an ARP request and receiving an ARP replay must occur again to enter the map in the ARP table. By using the command show IP ARP on a Cisco router, we will be able to see the ARP table as it is here, and by using the command ARP-A, we will be able to display the ARP table on a Windows as it is shown here. As a broadcast frame, an ARP request is received and processed by every device on the local network. On a typical business network, this broadcast would probably have minimal impact on the network performance. However, if a larger number of devices were to be powered up and all start accessing network services at the same time, that could be some reduction in performance for a short period of time, as it is shown in this figure. And after the device sent out the initial ARP broadcast and have learned the necessary MAC addresses, any impact on the network will be minimized. But in some cases, the use of ARP can lead to a potential security risk. A threat actor can be there and can use an ARP spoofing to perform an ARP poison attack. This is a technique used by a threat actor to reply to an ARP request for an IPv4 address that belongs to another device, such as the default gateway as it is shown in this figure. And in this case, the threat actor will send an ARP reply with its own MAC address, and the receiver of the ARP reply will add the wrong MAC address to its ARP table and will send the package to the threat actor instead of sending those packets to the default router. Enterprise level switches include mitigation techniques known as dynamic ARP inspection, but this is beyond the scope of this course. IPv6 Neighbor Discovery Protocol is sometimes referred as Neighbor Discovery or Neighbor Discovery Protocol, but we will refer as Neighbor Discovery, which provides address resolution, router discovery, and redirection service for IPv6 using the Internet Control Message Protocol version 6. This protocol can have 5 Internet Control Message Protocol version 6 messages to perform these services. They have the neighbor solicitation messages, neighbor advertisement messages, router solicitation messages, router advertisement messages, and redirect messages. Neighbor solicitation and neighbor advertising messages are used for device-to-device messaging, such as address resolution, similar for address resolution protocol at the IP version 4. Devices include both host computer and routers. And the router solicitation and router advertisement messages are messages between devices and routers. Typically, router discovery is used for dynamic address allocation and stateless address auto configuration, as it is shown here. As like address resolution protocol for IPv4, IPv6 devices use IPv6 neighbor discovery to determine the MAC address of a device that has a known IPv6 address. Internet Control Message Protocol version 6 neighbor solicitation and neighbor advertisement messages are used for MAC address resolution. This is similar to address resolution protocol request and address resolution protocol replies used by ARP for IPv4. So let's assume that PC1 wants to ping the PC2 and use the IPv6 address as it is shown here. To determine the MAC address for the known IPv6 address, the PC1 will send an Internet Control Message Protocol version 6 neighbor solicitation message as it is illustrated. And the Internet Control Message Protocol version 6 neighbor solicitation message are sent using special Ethernet and IPv6 multicast addresses. This allows the Ethernet network interface card of the receiving device to determine whether the neighbor solicited message is for itself without having to send it to the operating system for processing. And the PCT will reply to the request with an Internet Control Message Protocol version 6 neighbor advertisement message, which includes its MAC address. And this was the material for today for the address resolution, where we check the address resolution protocol for the IPv4 network and the IPv6 neighbor discovery for the IPv6 network. See you to the next session, and for those who are new to this channel, do not forget to subscribe and hit the notification button for the new videos that will come up. Thank you.